Okay, hi everyone. Welcome on this new stream on Module 17, the first of the year. So first maybe mic check and all, is everything correct? I can see myself on the webcam and it looks like the microphone is working good. Hi Pierre, hi Hervé, how are you doing? Well, I know how you are doing, anyway. So yeah, today I want to show the progress that I've been doing, that I've made on Module 17. Hi Philip, how are you doing? So yeah, show the progress of what I've been doing on Module 17 and solve a few issues, because here is what it looks like for now. So I think it's the first time that I'm showing this like for real with the screen and all. This is the back side of it. So basically this is what I've been doing for most of my time now, designing the enclosure in the different faces. So for those of you who remember, we chose a Hammond enclosure, which is 10 by 8 centimeters. Let me see if I have one which is still intact. Yeah. So this is what the enclosure looks like by default. So aluminum extruded, basically. So this is an aluminum profile which, yeah, they cut to length. So this is 8 centimeters long extrusion length, if you want. And you can't really see this because it's still in its plastic wrap, but you have the face here, which is basically this aluminum plate, which you can slide on and off. You also have the side panels here, this one and this one, that you can remove, and it's just like simple aluminum plates. And those three are basically 1.5, 1.6 millimeters thick. So basically the thickness of a PCB. So we decided that we would just replace those with PCBs. And the reason we did that is that because it's much easier to design and order a few PCBs with cuts and writings at the right place. And so we have a custom front plate basically and a custom back plate. So that's what it looks like. So yeah, we have, so this is the back plate and this is the front plate. Basically two boards that you make in KiCad for the correct, to be the correct size. And yeah, what required the most time and was the most time consuming is the human machine interface, as I called it throughout the project, so HMI. This is what it looks like straight from JLC PCB. You can see that we still have the rails on top and below, which were added for production concerns. And yeah, so the main criteria for this HMI was that I didn't want any components to be mounted on this face, except of course for the screen, because otherwise you can't see it. So the only way I found to have buttons that are not mounted on the top side is to have capacitive touch buttons. So that's why you have like big circles on the board. Those are basically capacitive touch electrodes. You touch them and it's supposed to react. However, JLC PCB doesn't have each and every component in stock, and so they were not able to mount those. So you can see that if you look at the board, you have like this footprint, this one, yeah, this one, which is a voltage regulator, and also here you have a few LEDs which were not mounted, and here is a switch. So I'm still waiting to solve a few issues with various providers looking at UDG key, customer support, awfully slow, the most terrible I have ever seen, and I'm still waiting for them to solve something before I'm able to order those components. But anyway, the goal is to order those, mount them on the board, and check if it works correctly. So this is a side-by-side comparison of the board and the board with an enclosure. Of course, those are the same size, but what you can maybe see is that the screen on this one is larger than the screen on that one. So yeah, I think it's gonna help a bit with the reliability, the readability on the screen. Maybe for those of you who don't have as good of a sight as I have. So yeah, that's currently the status of it. So this is what I call revision 0.99, because of course you still have a few issues to sort out before you release the last revision, which would be revision 1.0, at least for the time being. You basically have all the same functionalities as previously, which is you have the Kenwood connectors, volume control, DE9 connector for the packet radio mode, USB and 12 volts input. You flash the radio by pressing escape and plugging the board. We have moved the reset button on the side, of course, so that it's compatible with the enclosure. And we also have now the possibility, of course, to have the baseband tuning either with multi-turn potentiometers here or with software potentiometers, which are not fitted on this board. And of course, I made a mistake when I ordered the parts, so those potentiometers are not the correct ones. So I still need to order a different reference and mount them on other boards. Anyway, yeah, so that's pretty much it for the current status in the presentation of the project, I believe. Let me know if you're listening and if you have any question. Yeah, so I still haven't been able to test this to see if it works, but I tried to make it so that everything is gonna be compatible and gonna be the same, except for the flashing, which so we have a slide switch which is mounted on the corner here, and you have an opening in the back plate here, which will allow you to put the board in either run mode or firmware update mode. Yeah, so you won't have to press escape, you will just toggle the switch to be in the mode you want to be in. Because the capacitive touch button made it way too hard to implement, so yeah, anyway. So this is what it looks like, this is how it is for the time being. But we still have a few things to do. First of all is that the HMI board is not exactly at the correct dimensions, so you don't see it. But let me just maybe do I have some pliers somewhere? Be right back. Okay, so it's time to open the enclosure and show you the issues I've been having with this. So removing the side rails. So this is the naked board. And you can see that it's exactly the same size as the cover, which sounds great, until you realize that it's not great at all, and this was a design mistake. So let me open the enclosure and show you piece by piece what does fit and what does not fit. So if I can open this. Great. So this is the naked enclosure. Well, the main part of the enclosure at least. So you can see that we have some rails inside in which we can slide the board. We also have a rail on top here in which we slide the cover. They call it the bottom cover, I call it the top cover because anyway. So if I slide the cover in, it's snug, it's nice, but if you have a look, I don't know if you will be able to see this, we can kind of see that the board is not snug because of the width of the small flaps here, but because of the top ridge here, basically. So this is the edge which is against the rest of the enclosure and making it a snug fit. It is not this, it is not, sorry, this edge, it is, sorry, it is this one, not that one. So it means that when I slide HMI in, well, I can move it from side to side and it's way too narrow. So it needs to be enlarged at the very least, and turns out that it's so those holes are the exact same dimensions as wood skewers that you would have in any kitchen, and if you fit that in the hole on each side, then the HMI board becomes a snug fit. So that's the solution I opted in for this one, but of course we need to redo it so that it's the correct dimension straight out of the box. So that's maybe the first thing to do, and for this, how should I do this? Maybe let's first have a look at the drawing to see if by any chance we have a dimension that we can refer to. So this is the drawing. So basically, yeah, you can see that this is the edge in contact with the rest of the enclosure, this one. And I thought that this was gonna be enough, but this is definitely not. So this needs to go inside the hole so that it is a snug fit anyway. So yeah, but we also need to have the space for the screws, so we can't enlarge the board on the whole length. We need to keep some clearance for the screws, and sorry, where is, here we go. So you can see that on the profile of this board we already have some clearance here on the edges, and this is good, we want that. But we need to move everything so that we are still good with the screws, but we don't have this loose fit. Let me grab a screwdriver and make some measurements. So this one and this. So we will pop the cover. Also, those screws are thread forming screws, which are a pain to find in any basically hardware provider. I have somebody who helped me on Discord finding a good reference, and it looks like the only standard that he was able to find which fit my use case is DIN 7500. And it turns out that DIN is old kind of standards, German standards, but also it's one of the only DIN standards which haven't been translated in an ISO or EN standard. So I'm screwed, pun intended. So I don't know if I will be able to find the correct screws for this. I'm still looking for it. It's a bit difficult. And because of course, nothing is ever easy, the metric diameter that matches those screws is M3.5, which of course is rare and nobody has it. Anyway, so you can see here that I have some wood skewers in it. And so how should I try to measure? Maybe I can try. Okay, let me take my caliper. Okay, here we go. So we have 2.7 millimeters, basically 2.7 millimeters from this point to this point. And I guess it's symmetrical, I hope. Yes, it is. And so what's the total length of it? So I would have about 102.3 millimeters minus 2 times 2.7 minus some clearance. So that would be 96.9 and make it a bit less, maybe 9, especially given that JLC PCB's cutout for the board is not really precise, so I don't know. I think 96.5 millimeters would be alright. So I'll open the board and try to see what modifications I can bring to it. And the good thing is that it stays below below the 10 centimeters. Well, it's a 4 layers board, so actually we don't really care about that. The 4 layers board on JLC PCB have a special discount if you are below 5 by 5 centimeters, which is ridiculous. Anyway, so that's the KiCad project for the board. Yeah, maybe you have noticed, I don't know, that we don't have that many vias that you can see on the board because I asked them to fill the vias with epoxy and cap them with copper, so you don't have gazillion holes on the board, which would make it way more ugly. And so we just have a few dots basically, which are okay. I mean, when some vias come from below, this can't be avoided, so yeah. Anyway, I have to make this wider, and let me also check if the clearance for the screws is enough. What does it look like? This could be... This could be made a bit wider on that side, but I don't know if we gain anything doing that. I'm gonna make it like 0.5 millimeter wider on each side for that. Yeah. Let's try to take some measurements to stay objective. Yeah, good enough. Just so that we hide the sliver. So we have a silver sliver here on the side. The goal being that each and every part of the board and the module basically can be galvanically connected for the grounds, just to improve the shieldings and all. So if you want to improve the shielding, you can always scratch the anodized layer on the board, on the enclosure, and it will make galvanic contact, and all the parts of the enclosure being connected and tied to ground is gonna shield the board. Hi Bastien, how are you doing? So have you seen already what Module 17 looks like in its enclosure? So I have removed a few parts now because I'm already taking some measurements to bring some changes, but I have this board with the display, and this is basically what it looks like from the front of it. And you can add the faces. Anyway, so let's bring changes to the file. My God, I don't have enough space on this desk. It's a nightmare. Oh yeah, maybe just a side-by-side comparison of this board that I played with but never worked. Not that the revision is flowed, but this production batch was flowed. So this is what it looked like, and this is what it looks like. So I pretty much like the new design. Oh, sorry, it was upside down. But I mean, maybe I like it more because I did it, so who knows? Okay, so this is 91.5 and I said this has to be 96.5, so I have to add 2.5 millimeters on each side regarding this edge. Maybe I can already move it. Like this. This edge has to move by 0.5 millimeter. This one too. Like this. Same thing for these segments. Like this. Now those. And this one has to move by 5 millimeters. no, 2.5, sorry. 2.5. Like this. Okay, good. This. So this one, I mean, how does it compare? Can I see? Oh. Okay, so the thing is, do we want to modify this or not? Maybe we just want to draw something from here. No, bad layer, that's not the problem. I will fix that. From here, and not on this layer, but on the edge cuts, and it has to be 0.15. Edge cuts 0.1 or 0.15, 0.1. Okay, good. Yeah, I will just draw this first, and then we will see if I do it in another way. Oh yeah, this hasn't been updated yet. Same goes here, I guess. So yeah, it looks like I have to drag it like this. Same thing here. Is it good now? Yeah. Looks good. Okay. So I guess I also need to edit this rule area. 2.5 right here. Okay. Oh, and I guess which is the, oh no, it's on the mask layer. This zone needs to go to here. What did I do wrong? Hey. Oh, yeah, this one also needs to move. This is the main copper plane. Okay, yeah, this is more like it. Maybe I'm also gonna move the mask area. Move this edge half a millimeter outward. Like this. Same for this corner. And I guess those vias will need to move too. Let's select vias and select those. Like this. Looks good. Okay, so now let's replicate the changes on this side. So first, let's select everything. So this is the exclusion area, which needs to move by half a millimeter, by 2.5 millimeters, sorry. Like so. Same for the corner up here. Perfect. Copper plane need to align to here. Oh no, this is not the copper plane, but doesn't matter, it also needs to move this is a rule area. No worries. Okay. Can I select the copper pole here? Rule area. Okay. Oh. No. Zone. Okay. Ground. This. Come on, guy. Need to move here. And top one. Same thing. Okay. Rule area. Okay. Looks good. I also need to move this. And this. Okay, so the mask area, this one need to move 0.5 millimeter inward. Like this. The vias need to move. Oh yeah, first need to... Come on. Okay. Okay, so this board should fit way better in the enclosure than the last one. I'm also gonna enlarge the text here, which is not... I don't like it that much. It's too thin, basically. So let's see if I can do something for it. Can I make it bold? Yeah. Yeah, that's not major difference, but just slightly. Maybe I can also make it a bit larger. 1.9. Let's check. Okay, make it better. For the rest, I think it looks good enough. I don't think I have any modifications to bring on this side of the board. So you can see that the screen for now it's just taped because I don't have any other way to make it hold in place. And I don't want to glue it immediately. Also, so you have the connector which goes up, goes into the notch that we can see on the screen right here, and goes down this way up to down to the connector that we can see right here, this one. So yeah, that's how I did it. I think it looks very neat and very clean. I really don't. Yeah, I think it's nice. So yeah, I'm still gonna wait for the missing components anyway before sending the next board into production. But maybe I'm gonna just do an order of the board without any component on it, just to check for the mechanical clearance and fittings and so on. So for that I'll see what I do, but yeah, I think that's what I'm gonna do. We will also add the various reference for open source hardware licensing and all. Okay. I also have some issues because the face plates here for the front and back, they are slightly too wide, which makes them a bit hard to fit in the bezel here. So I want to sand them down a bit to make them the correct size, measure it, and and bring this change on the board so that they are the correct size right out of production. But I mean, it's not a problem if it's a bit too narrow because it's gonna be screwed down anyway, so better be safe than sorry and make that slightly smaller. Okay, so that's what else? Yeah, okay, let's reassemble the module, because I want to show you another problem that I've been having, and which is linked to those bezels too, I believe. So I'm not gonna screw everything down, but if you look, you can see that it moves quite a bit inside the enclosure. I think the main problem is that those bezels, you know, they have a small lip inside here, which maybe you won't be able to see, I don't know. Anyway, there is a small lip here. Yeah, a bit hard to see. Maybe like this, you can see it. Yeah, the lip here. Which, so it's large enough that the board here do not restrain the movements of the main board inside, but they are not wide enough to keep the board from moving. So the issue is that they advertise this as an enclosure for 10 by 8 centimeters in size, but it's actually more like 10 by 8 point something. This point something has its importance because then it moves inside and it's very annoying. And so this bezel is, I don't know, about 1.5 millimeters thick. This the lip, and make it twice that for the fact that there are two of those, and then you have already a 3mm play for the main board here, and it's clearly annoying. So I would like maybe to try to measure by how much it does move, if I can do that. I'm just checking to see if I haven't forgotten anything. So let's try to see if we can measure by how much it does move inside the enclosure. If we can do that, we will be able to know by how much we need to enlarge the board. And let's this time put the screws in. Maybe I can first do something like this. Yeah, it looks like I have... It's recessed by 1.6mm, of course. How can I do this? Okay, I know. I can have an approximation of what I need. And the approximation says 3.3. Huh. Well, 2.7, 3.3, give or take. Maybe let's screw that panel down too, so that it doesn't move around. And check again. Sorry, this is not the most exciting part, and it's difficult to show at the cam because first, I'm not a machinist, and second, well, I don't have a big streamer setup, so by half eyeballing it, it looks like 3.2mm, which is about 2 times 1.6, which is about 2 times the lip of the set bezel. So I can try to take this one out and measure. Can I pop this out? I have to take my pliers. Okay, right. Okay, And how thick is this one? Of course it's 1.4 because of course. Aha. I also see that the PCB is not flush against the lip. Quite difficult to measure this way, especially because of this annoying little thing. Oh, sorry, space heater is kicking. And it looks like indeed the PCB is about 1.6. Okay, I just wanted to check that the play I have on the main board is indeed correlated, highly correlated with the lip that I found. Well, that I know I didn't take into account. So now that I'm sure that it's highly correlated, I know that the mechanical, the length I have to add is about that, basically. So let's save this and open the main board and do some changes. So how much should I add? Let's add 1.6. Yeah. Because, I mean, if the board is slightly too large, it's not gonna be a problem because of the screws, which are gonna be able to press it in and stop it from moving, while if the board is too short, it's gonna move inside. So I think I need 1.6 minimum. I would even say maybe 1.65. Yeah, let's add 1.65. Okay. So first I'm gonna move the edges of the board by 1.65 millimeter on each side. I can move those two at the same time. Oops, sorry. 1.65 like this. Oh, this one needs to move by that much too. This needs to move. Oh no, it's can I drag from here? I don't know. Doesn't look like it. Okay. This corner needs to move too. This needs to move. this too. Then drag this. Yeah, okay. So that's good. So now, which components do I want to move by how much? So this one will need to move. Okay, so basically on this side, all those components need to move by 1.65, except for this one, which I think I will make it move a bit more. Just because I want maybe this to be near the edge of the board, so that it's, yeah, but not exactly there, because what you will quickly see is that components, I don't know if it's JLC PCB's precision or what, which I don't think it's only JLC PCB, but those components move and they are not exactly at their theoretical position. So those two, for example, those two components that you see on the screen here might move like this, you know, basically they have their own little freedom and life of themselves, and it is related to the size of the holes and all. So maybe it would be an idea to try to make a few holes slightly smaller, so that the fit is more precise. Like for example, this barrel connector is, I think, we really need to modify the holes here. But I don't know if it's like the quality of the piece, of the component, or if it's the hole that is designed a bit too large, but it's, you can see it, that it's not straight. Yeah, I think you can see it. You see that it's moving like, it's a bit like this. So yeah, that needs to move. Anyway, so first let's let's move the holes, mounting holes by 1.65. Same for this. Okay, and last one, this one. So this, yeah, let's move everything before moving the components so that we are not screwing the board up. Okay. And the last corner, which is this one. Okay. All right. These also need to move, but it's easier to move those like this. Up and down. Oh, there are two of those that I... Oh, maybe I can replace those with areas. Like if I do this and I select bottom and top mask solid fill, I think it's easier because I only have one area instead of two shapes. Yeah, of course I need to move 1.65 millimeters down from there, like this, corner here, and corner here. So can I graphics, is it this? Yeah. And this one. I'm gonna bring the same chain here, so area here, front and bottom mask, solid fill. Okay, 1, 2, 3, 4, and close the loop. So if I do this and I look at the board, yes, looks good. So of course the vias, maybe we'll need to add a few vias. That's not a big deal. Okay, so now to move the components on the edge. So footprints, no, I have components. Oh yeah, no, it's component footprint, yeah, of course. This one, this, oh yeah, this is a group, so no worries, we'll do that later. Oh, no, sorry, I misclicked. This one, oh no, can I open the, come on. Yeah, of course I can't. Okay. And then of course we will need to move some tracks and all around. That's no problem. We will do that. Those two footprints need to move. That's weird. I can't like select components in a group anyway. Then of course we will need move that one a bit more later on, but no big deal. Let me just, oh yeah, I forgot about something. I need to pay attention to that too. Sorry. Unscrewing everything again, losing some screws. Come on, come here. So I put the net here, which, yeah, I put it here to not be in my way, but now I want to remove it because it's not, it's definite, it's final position. So yeah, I don't know where I screwed them. Okay, good. Yeah, okay, I just wanted to check that these were not in my way, which they are not. And if I screw them here, so yeah, the board, yeah, so if I screw them, if I screw this down, the board doesn't move, only the HMI which moves slightly, which maybe I will look into that too later on. Yeah. Yeah, of course the HMI will also need the same modifications in that dimension. Anyway, so this doesn't move anymore, which is great. But then I don't know. So of course those connectors are recessed in a way that make them not really accessible. So if I try, for example, USB-C, am I even able to plug it? No, I'm not even to plug in the USB-C connector. So yeah, this needs a fix definitely. Yep. Okay. Let's move. No, this one, do I want to move it? No, I would even say that should I? Sorry, I'm not sure of what to do. No, I think this position is perfect because it's almost flush with the board. And if I move it, it's not gonna be flush anymore. So this, and this, it all needs to move. Like this. I would even try to move this footprint right like this. Yeah, I'm gonna move it as much as possible toward the edge. No, sorry. I need to keep an eye on this. Sounds nice like this. yeah. I don't think this one needs to move any much more than this, and of course fixing the broken wires and all. Oh yay, fun. This is broken, and yeah, okay, yeah. So by how much did I move this one in the end? Moved by 1.99 millimeter. So let's move those by that much. Yeah, I can do that for quite a few bits of wire, I think, which will make the task a bit easier. Yeah, so those two can move. Do I want to move everything? Maybe it's easier if I simply like move everything up by 1.99. Move positioning tool, move exactly like this. So this moves like this, and I can select the differential routing tool, do like this. Huh, where does this come from? Oh, I think it was like here, not a big deal. This. Okay. Yeah, as always, I'm sorry, it's not the most exciting bit, but hey, it has to be done. Okay, let's already, oh no, yeah, it won't work because we have lots of broken tracks down and here too. So this also needs to move, so I placed it to avoid having those slivers around the track, which goes in the middle. Though, oh, that's funny. Okay, yeah. I just need it to go up to here, like this, and this, and it needs to go down to here. Okay, good. This, and this. Okay, nice. This track is broken. No, it's not anymore. Okay. Looks like this area is good to go. Maybe, oh yeah, I can move this a bit. I don't have to move it by the same amount. Yeah, of course this needs to move, and I can move it by hey, but I have been moving everything by 1.99. No, yeah, okay, not a big deal, I guess. So long as there is no DRC error or something, or ERC errors. No, design rule checks. Okay. Anyway, so I don't know. How are you doing, guys? Feel a bit lonely tonight. Not much activity. I don't know if it's because we are Monday or what. Okay. Now to fix the things down here. 1.65. Don't I have a key to repeat? Oh, no, I don't. How sad. It would have been very, very useful. yeah, let's try to keep those pads aligned so we don't have any useless bits of track. We can just do, no, sorry. Like this. Okay, like that. Same goes here. Okay. So it looks like this is fixed. Let's see if I can move everything here easily. Yeah, this is gonna be a lot of stuff to move, it looks like. Anyway. No, not this one. Okay, looks good. This also needs to move. Hey. How is it that it has been reallocated to ground? No. Maybe this needs to move out of the way? Is it? So those segments move. Yeah, this via. Huh, that's funny. Oh no, okay, yeah, this needs to move to, but yeah, it's already relocated to +5 volts, so let's do it like this. And then like this. Okay, yeah, nice. Here, a few things to move to. No, did it? Oh yeah, those positioning to move like this, and so I guess this one needs to go down here, VDD here, and this track also needs to move like so. Okay. This needs to move down, and let's redraw this. Okay, nice. Yeah, so this, that's not a big deal. This can just move like this. This, of course, it's not good. Not really, yeah. Don't really need it, but we can still move it. Speaker volume, we can move it like this. So the label, reset label, move like this. This, come on. Okay. Okay, it looks like it's almost done. Do I have anything on the bottom side which still might create some problems? Doesn't look like it. Yeah, this also needs to move, and I can move this with it, I guess. So, by inspecting the board in the 3D viewer, yeah, OHIS label needs to move. Module17 logo can move slightly. Same goes for this one, OpenRTX logo. This one I'm gonna move it a bit, but not as much. I think 1 millimeter is gonna be enough. Of course I need to move this via which is in the way. Okay, good. And this track which is now too long. Okay, here on the back looks good. Huh. Okay. Okay. So now I want to move this a bit more. And maybe I can just first like do this. Oops, no. So align those, but then because I don't want them strictly aligned, maybe just to be on the safe side and not have it. No. I don't know. So it's either I put it flush, but not exactly flush, because then it has the risk of preventing me from having this go flush against the edge of the board. It's not gonna be flush, probably not gonna be able to be flush against the edge of the board and the potentiometer. But I would like to have the thread be a bit longer here, so maybe I will just move it by, I don't know, let's say 1 millimeter. Then here I need to move this track down a bit. Okay, what does the DRC says? Do we have a gazillion mistake or what? Come on. Track has unconnected end. Does it? Yeah, of course, those are in the way. So what does this say? Oh, it does not match copy in library. Yeah, because I think it's because I added the 3D models or something like that. Yeah, it's too bad that it doesn't give the difference, but yeah, I think that's it, because the models are not free, so I was not able to include them in the M17 library. So I had to edit them by hand. Track has unconnected end. Oh, yeah, of course. Let's see. Yeah, maybe I can just move this up a bit. Footprint component doesn't match footprint pads. Expected through-hole actual is SMD. Okay, why not? Clearance violation between via. Okay. Okay. This, yeah, I don't want this to be in the footprint. Let's move it this way. Oh, and I am missing some vias here. Oh no, it's not. It's just that I didn't move those, I guess. And this is minus 1.99. Yeah, exactly. Same for those. Positioning tool, move exactly, okay. Now I still want to add vias here and there. Like that. Okay. Track has unconnected end. Really? No, it doesn't. Clearance violation. Oh, okay. Yeah, makes sense. Ah, yeah. Of course, this is not gonna work. And this is not gonna work either. Okay. So it's weird that this is registered as an... Oh. Okay. Huh. So yeah, it looks like it's not an SMD footprint just because of those four. So let's modify it so that it's happy. Well, I don't know actually. Is it? Sorry. I would say, yeah, let's not modify it. It was working correctly, so let's not care about it. So exclude this violation. Doesn't match copy in library. Doesn't match copy in library. Doesn't match copy in library. Same, 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 same. This we don't care. Oh, and this overlaps a bit. Does it? Well, no, it doesn't. Okay, good. So this board should fit better inside the enclosure. Nice. Okay. For the rest, I don't think I need to move anything. So I think the last step for this board is to add some vias here. So by 1 millimeter, so maybe I can add so how many vias can I add? Two. Yeah, let's make it 2 rows of vias. Same here. Is it in its own little... Oh no, no yeah, this via was in its own little group of its own, but I couldn't just remove this group. I have to do this, I guess. Why? Come on, ungroup. You do not get to be in your own little group. And okay, good. Okay, same thing on this side. And add some vias here. Okay. last check to be sure. Okay, nice. Maybe let's just to be sure for the time being. Where is it? Here. (0.99b). Just to be sure that I don't get confused with all the balls that I might have at the same time. I will move this one inward slightly bit, a teeny tiny bit, and it's gonna be enough. I just don't want it to be aligned exactly with the edge of the ball for the exact same reason that I didn't want. Oh yeah, but can I do that and move only that one? Maybe it's not a good idea. Let me take a speaker mic here and check the fitting. Yeah, I'm gonna move both. By 0.5 millimeter, it's gonna be enough. Maybe even less than that. Let me see. Maybe 0.3 is enough. Oh, wait. That's strange. Looks like I... Hey, what's happening? It's fucked up. Okay. Okay. I still can't move freely. Why is it? Oh. Okay, it looks like I pressed the key and now... okay, yeah. The grid. Okay, great. Yeah, we don't have much more to do than that. Check again the DRCs. 2 footprints. Yeah, it doesn't match copy in library. I know that. That is made on purpose. Okay, yeah, I prefer this. Okay, so I would say that for the board itself, it looks like we are good now. Maybe still a few. Oh yeah. So for example, this label can move up. Move exactly minus 0.65. And same thing for this. Move exactly like that. Nice. Okay, I just want to check what they say in this footprint and to make sure that this footprint has been designed according to the manufacturer's recommendations. Well, that settles it. It's a footprint from the KiCad library, so I'm gonna trust it and not modify it. I think it's better to be safe. Okay. Yeah, maybe last change is gonna be HMI board again. By how much does it move? It's a bit hard to say. I'm gonna try to measure it roughly. Looks like it moves by 1 millimeter, which is weird because I don't know against what it is hitting basically. So I'm just gonna see if I can unscrew this and check what it is touching. I expect it to be bumping against the board. It's the PCBs from in the bezels, or oh, not really, because of, I guess, yeah. Huh. Okay, interesting. Let's see, because maybe I don't even need to touch this board again. Not sure. yeah. What's the size, exact size of the ball? Maybe it hasn't been produced exactly at the correct size. So it is, yeah, 80.04. So yeah, maybe making it like, I don't know, 0.1? No. I won't touch it. I think I will leave it like this. So now I want to check something. So recent. Where is it? Is it my desktop? Yeah, okay, right here. Can I? Oh, what? Huh, okay. That's strange. Okay, the file is in cache. That's okay. I don't remember how I. Oh yeah, I think I used KiCad step up or not. Oh, I'm one commit behind. Okay, let's let it check for all the updates and apply updates. Okay, and of course it's gonna restart. Okay, don't remember if I did it using this add-on, KiCad Step Up add-on, or not. Let me see. Yeah, if I have, yeah, okay, I think I remember now. So I need to go here, export VRML, like this. Okay. And then for the main board, same thing. PCB editor, export VRML. This one takes a bit more time, and it's done. Okay. So now I can import. This one. And try to see if I can make it the exact, place it at the exact same location. Like this, we can check how it should look like. Oh, it shows that it's colliding. Oh, strange. Well, the thing is, I trust my eyes more than I trust those 3D models, which are not that accurate, it looks like. Okay, so yeah, I don't think I'm gonna bother with this anymore. Maybe I can just, yeah, no, I'm gonna leave it like that and call it a day. So that's gonna be it for today. I don't know if there is at least one person still listening at me. Anyway, for whoever is left, thank you for following along today. I hope you enjoyed it. I don't have any other stream plans anytime soon, because lots of things to do. I'm gonna have some code to do. I'm also spending some more time on OpenHT now, getting back to it. The audio subsystem is now kind of working. We do have something resembling an audio output, which is nice because we needed it. So maybe we will be able to RX soon with the OpenHT. It is still to be seen. Okay, I don't think, yeah, for those of you who are listening and that know about FOSDEM in Brussels, I will be with Silvano from OpenRTX at FOSDEM the first weekend of February. So from the 2nd of February to the 5th of February, I'm gonna be in Brussels at FOSDEM. We do have a talk about M17 there, so if you are in the area, anyway, come and say hello, please. There is gonna be an info booth about ham radio there. This is all gonna be focused on open source in amateur radio. Of course, this is FOSDEM. This is not just a ham radio exhibit. So yeah, if you come to FOSDEM, please say hello and check out the talks about the amazing folks in the software-defined radio and amateur radio dev room. So I know Bastien here has spent quite a bit of time organizing all this. He made a fantastic job. So yeah, please come and join us. Okay, that's gonna be it for tonight. Thank you for following along. I hope you enjoyed it. See you on the next stream and 73s. Bye bye.